Welcome to our video on understanding the z-table. We are your tutors. I am your Zafira Vilasaka.
I am Maricati Bacat.
I'm Robert Gabriel Pandan.
I am Chelsea Misty Dela Cruz.
We are the Z Masters. Today, we will break down what a z-table is.
So first, the basics. Do you know what a normal distribution is? It's a way to describe how data is spread out when most of the results are average. For example, imagine that we're measuring the height of every adult in the city. We would find people of medium height, some extremely short, and some are extremely tall. If we drew this in a graph, it would look like a bell. That is why it's called a bell curve.
So, to be clear, let me say it again. A normal distribution is a type of continuous probability distribution where data clusters around a central value or mean with symmetrical tails. Its key characteristics are bell-shaped curve, the mean, median, and mode are all equal, they're the same value. It is symmetric around the mean, and lastly, it is defined by mean and standard deviation.
So then, what does standard normal distribution mean? A standard normal distribution, also called a z-distribution, is a special case of the normal distribution with mean is equal to 0 and standard deviation is equal to 1. It is used to standardize scores by converting it to z-scores. Compare different normal distribution and find probabilities using z-table because it uses z-scores from the z-table and it doesn't use real-world units like inches or grams.
So then, what is the difference between normal distribution and standard normal distribution? In normal distribution, the mean and standard deviation can be any value because it describes a general data set. While in standard normal distribution, the mean is equal to 0 and the standard deviation is equal to 1. It is a specific normal distribution used for standardization. Think of it like this. Normal distribution is like any height distribution in centimeters. Mean is equal 170, while standard deviation is equal to 10. While standard normal is like converting those heights to z-scores. Like mean is equal to 0, while standard deviation is equal to 1.
So, this is a z-table. This row here represents the whole number and tenths of the z-score. It represents the z-score up to first decimal place. For example, 0.0, 1.2, and 2.5. In this column on top represents the z-scores hundreds. It represents the z-score second decimal place. For example, 0.00, 0.01, and 0.02. So let's have an example. For example, your z-score is equals to 1.25. So first, look for 1.2 on the left side. And then, move across 0.05 on the top. The area where they meet, which is 0.8944, is the probability of the z-score. So this number inside are probabilities. They show us the cumulative probability or area to the left of the z-score. They tell us how much of the data falls below a certain z-score.
Let's try an example. Find the area to the left of z is equals to 1.25. So step 1, locate 1.2 in the row, which means we need a z-table. to locate 0.05 in the column, which means we're gonna go to the right. Step 3 is read the value where they meet, which is 0.8944. The value is 0.8944. We're gonna move 2 decimal to the left. 1, 2. What does that mean? That means 89.44% of the values are below z is equals to 1.25. So that shaded part represents the probability.
Now, let's talk about common mistakes. First, some people forget that the z-table shows area to the left, not the right. Z-table gives probability z is less than small letter z, which is area to the left of z. Not probability big letter z is less than small letter z, that is area to the right. Here are some examples.
Another mistake is mixing up positive and negative z-scores. Z is equals to negative 1.5 is not equal to z is equals to 1.5. Symmetry matters. Pay attention to the sign. And sometimes people shade the wrong side of the curve. Left tail is not equal to right tail in graphs. Visualize. Draw the curve and shade what you need. And sometimes they just copy the value without explaining what it means. 0.975 from table does not equate to done. It means P, the quantity of Z, is greater than Z scores, is equals to 97.5%. Explain what the number means.
So, why is the z-table important in real life?
We use it in exams, test scores, IQ results, height, and maybe other real-world data.
Helps us understand how likely is it something to happen.
Remember, once you understand the basics, the z-table becomes a powerful tool.
Practice is the key.